Right, hello and welcome back to another video. So one of the comments from last week's video was to do with particle size scaling. Can we do some scaling based on distance? And the answer is yes, of course we can. So we're going to have a look at it in a few different ways. First off, in a material, we can do this in the vertex shader in materials. Then we're going to have a look at particles, and we're going to see it live at runtime using the particle update step, and then we'll do it again just as a kind of like a one-time thing on Spawn. And so we'll talk about kind of the costs and things and why you might want to do it in different places and that kind of stuff. So as an example, what do I mean? Well, here we have two cubes and a kind of bunch of particles. If I move the camera away at a certain distance, the scale of those objects obviously gets much bigger, all completely based on the camera. Other way around, if we get really close to the object, you can see here I'm getting closer to the cube, but the cube's actually shrinking until at some point it just disappears entirely. Similarly with the particles, as I get closer towards them, they are shrinking down to nothing. So why might we want to do this? Well, the shrinking particles when they're close up, that's a very common thing to do. If you've got an emitter or system like this, very small particles, when they're further from the camera they're small and look good. As you get close to camera, occasionally you get one right in front of the camera. If I move the camera here, just turned off real time for a second so I can kind of move around here, I'm really close to this. I don't really want to see a big thing because that's not really realistic. We're talking about little embers, dust motes, stuff like that. That's always going to be tiny. We can't represent it at real world scale because it would be too small and you can't deal with that. So instead we make them bigger size, but then as we get close to them we shrink them down, and that's very handy for particles, and that's what's happening here. Apart from it's not, because real time's turned off. Now it is. As you can see, they're kind of shrinking away. So the other thing that you might want to do is make things bigger in the distance. Generally this is sort of for stylistic or gameplay reasons. If you had something like a bonfire, say you're making a Dark Soulsy type game, maybe the flames from the bonfire want to be a bit bigger as you're far away so that they're kind of scaled up, a bit easier to see, a bit more kind of manageable gameplay wise, or potentially even sort of a feature on the map. If you're making a really big open world game, you could have a kind of castle or a building, some big feature or point of interest. You could scale it up in the distance, so as you're far away from it, obviously you can adjust the sort of speed and size and everything as it scales. But maybe let's just do that for a second. So if I just quickly tweak these values so it makes a bit more sense. Start there and let's do 10,000 and just do 3. Don't worry, I'll go over all of this stuff in 8 seconds. But now the object's going to stay sort of roughly the same size when we're close to it, well, exactly the same size when we're close to it, and then as I sort of pull away it slowly gets bigger and bigger and bigger and bigger until far in the distance it's now scaled up. And we can do our scaling in one dimension as well rather than just scaling the whole object and that kind of stuff. So so that's what we're going to do and how we're going to do it, or why we're going to do it. So the next question really is how we're going to do it. So first we're going to start with material, and I'm just going to do everything from scratch today. So M class size by distance SBD, let's call it that. Let's give it a quick colour. I like a nice mid-grey or dark grey. There we go. And actually Unreal has a node or a module. It's going to do a lot of the work for us here in this first example. It's called camera depth fade. And it's designed for use in that first use case that we saw, the fading out something close to the camera. But effectively all it does is it gives us a gradient based on distance, and so let's have a look at that first. Let's do just an emissive here. So there's two values, a fade length and a fade offset. The fade length is how many units does the gradient take, and then the fade offset is where does that gradient start from. And so if I just make a parameter for both of these, we can plug in some values and have a look. So the default is 512 and 24. So we'll start with those values, and we'll have a look here. So what's happening? So as I'm far away from the object, I'm getting a value of 1 here, a value of white, and let's do debug scalar values as well, just to make it super clear exactly numerically what we're getting. So we're getting a value of 1 here, and the distance from the camera, and then if I get closer and closer to it, you can see that value scales down until at 24 units now it's set to 0, and we get closer and closer and closer. And that's it. That's what it's doing. That's what the node does by default. If I change this to say 500 and let's say 1000, now the first 500 units close to the object are all going to be 0, and then suddenly it's going to start scaling up, and then at 1000 units, so at 1500 units, is going to be the maximum, where this is now 1, because it's this value plus this value. So this is where the gradient starts, and this is where the gradient starts, and this is how long the gradient takes. If I just quickly bring up a pen, if we have a graph, whoops, let's not use black and let's not use big. Let's do that. So if we have a graph, something like that, and this is our distance and this is our value, so let's do G for gradient and D for distance. Effectively we're doing this across and then up and then this and this. This is 0, this is 1. This distance here is our fade offset, and then this distance here is our fade length. And obviously we can set them to be whatever we like. Okay, hopefully that makes sense. Let's get rid of my pen for a second. So that deals with sort of near fade things. What do I want to do? Far fade? Well, in that case all we do is just make our fade offset very big. Now 5,000 units, nothing's going to happen, and then right at the end it's going to start fading up. We're not really going to see this. Maybe just tiny make out, probably not. That value has changed. If I go back to being colors, let's say it's black, and then it becomes white. So if we want it to be near fade or close up fade, we can use smaller values. If we want it to be further away, we can just use bigger values, and it's doing it all based on the camera. So what do we want to do? We want to scale our object. The way we do that is with a simple world position offset trick. So if I take the position of my vertices, world position, and I subtract the object position world space, this node here will give us the world space center point of the object's bounding box. So it's not the pivot. There is actor position if you wanted to use that. Right click, here we go, actor position, which would give you the position of the pivot. So you could scale from the pivot if you wanted, and that's how you could also kind of scale in one dimension and things. But in this case I just want to scale up and down. So by subtracting from here to here, effectively I'm getting a vector from the exterior point to the center point, and that's true for all of these points. So I'm effectively finding the sort of like scale factor vector, I suppose you might want to call it, something like that. So what do I do with it? Well, if I multiply it by a value, scale factor, and then plug it into a world position offset, this is an offset value, and so by plugging in 0 effectively here, by scaling by 0, we're not doing anything. But if I change this to -1, my object disappears. -0.5, it's now half the size. -0.25, you can see we're scaling down. So a value of -1 will make it disappear entirely. Value of 0 will do nothing to the scale, and a value of 1 will double the size. So it's kind of like off by 1. In fact, we could do that, and we could say scale factor, we could say scale, and then just subtract 1, and do that. That work? Yeah. So a value of 1 now becomes 0, we're adding nothing. A value of 0 in here will give us nothing. -1 will invert it. Yeah, that works quite nicely. So what do we need to do now? Well, we need to combine these two things together. So if I just take this value here, this is already putting an output which has been clamped, I believe. Yes. So we're clamping between 0 and 1. So if I take that value, multiply, and let's not actually multiply, let's lerp. So the values in here come from 0 to 1. If I use that as an input of a lerp, I can then have a size near and size far, as my two values in my lerp, and then I'm just going to subtract 1, and there we are. And let's put some values in here. Let's call it scale rather than size. Just nitpicking now, but there we are. So if I do scale near 0, scale far 1, and then set my values here, fade length to be 1000, fade offset to be 500. There we go. So my object is nice and visible. It's there at a scale far value of 1. So it's at a scale of 1, and I'm more than 1500 units away. And as I get close to it, it will start to scale down until it disappears. Pretty cool. If I want to do the other way around, so my near scale is 1 and my far scale is 5, but my fade offset is, say, 5000. Most of the time it's nice and small, or sort of default size, and then as I get further and further away, it then scales up. If you wanted to do both things at once, I mean, maybe you do, you just duplicate this logic, and so you can make this into maybe a function and what have you. Cool. Now there's a problem with this. It's looking alright, but this is on the far scale one, so it's going to scale up. Depending on what you're doing, maybe it's fine, but can you see it's kind of gone to a weird shape? What's happening there? Well, the verts on the object aren't all being affected by the same amount, so we get this weird kind of blobby shape. It's a bit odd. What's happening is the further away verts are scaling at a different scale. You can kind of see it in the gradient as well now, so I've got the nearest bit is black and the furthest bit is white. And if you want to fix that, I mean, maybe you're fine with that, but if you do want to fix that, it's pretty simple. If we open up the object or the material here, rather than using this node, what we're going to do is we're going to jump inside, have a look at what it's doing, and then we can kind of replicate that. So this is the inbuilt node. There are two sort of sections to this, pixel shader and vertex shader. We're dealing with the vertex shader size, but it makes it a bit more easy if we start with the pixel shader side. So this is the pixel shader side. We're taking the depth to the pixel, subtracting the offset, dividing by the length. So we're just sort of like refactoring those numbers, changing where they start from and end, and the scale of them, and that's really it. And we're clamping it. So we start with the distance, subtract the offset, divide by the length, and clamp. And on this side, in the vertex shader, rather than doing it with pixel depth, we're calculating a length. And the length is between the camera position, the camera world space position of the game camera, and in this case we're using the world space, absolute world space position. So this is using the vertex position. This custom node is just giving us a length. Not entirely sure why they didn't use the length node, but maybe there's a reason for that, but there we are. So what we're going to do, well, we're going to change this. Instead of being the world position and doing it per vertex, we're going to do it using the object position and do it for the whole object. So camera position world space, object position world space, subtract one from the other. That gives us the sort of the vector between them. We then do a length to convert that into the distance between them, and then we subtract our offset, divide by our length, and I'm just going to saturate, which is just the same as clamping it. So rather than using this now, I'm going to use this. And what we should find is the logic here is going to be basically exactly the same, because those four verts are pretty much the same. But now if we look at our cube, the whole cube is going to scale up uniformly, because we're not checking the per vertex distance to camera, we're checking the per or the whole object's distance to camera, and that works a lot nicer. Okay, so that's the material approach. As I say, the fading out close up or scaling down close up is a very common thing to do. Scaling things up in the distance occasionally happens, but maybe artistically doesn't make so much sense, but sort of more gameplay reasons might be something you want to do. But at the moment what we're doing is we're doing this on a kind of per vertex, per object. We're doing quite a lot of calculations to that. If we're dealing with particles, we can do the same calculation, and it will be mathematically exactly the same calculation, but we can do it on the particle position, and we're only doing it once. So even with our plane, or I mean this is a cube, it's chamfered, I believe it's called, yeah, chamfer cube. It has 138 verts. Each one of those verts is running the vertex shader, and then the vertex shader is having to do this calculation. Oh, that's not the one, it's this one, this class one. It's having to do each of these calculations. So even though they're all doing the same calculation, they're still all doing it. Now, there's not very expensive calculation, it's quite a cheap effect to use, but that doesn't mean we couldn't offset it. If we are doing particles, we couldn't move that to the particle side, and it would be cheaper again. So, so let's do that. So let's start with a Niagara system. Oops, this is all scaled horribly. Start with a template. Just going to use the hanging particulates template. There we go. So I'm just going to make these a little bit bigger by default. So just set the size up to like 10 or 15, something like that. Now we could do this manually in line in one of the modules, but I think it's a nice opportunity to get into a Scratch module. So I've just created a new Scratch module. I'm going to give it a name, SPD, size by distance, and we're going to get effectively the exact same set of information as we had in the material, and just do it for the particles. So we need the camera position, we need the particle position, we need these 4 float values, size, near and far, fade, offset, fade, length, and we can then do the same calculation. So camera query. This gets us the camera information, then allows us to get things such as the where's the CPU, camera properties, CPU/GPU. I'm just going to make this a GPU sim. It'll work on both, but I always like to work with GPU sims. Camera position. So camera position world, that's going to be exactly the same as this camera position here. We need our particle position. So particle position here, this is already in position. We can subtract one from the other, and then take a length. We could also have done distance, I believe, and just done the distance between the two. So there's a few more options available to us here in the sort of Niagara world. I don't think distance. Oh yeah, we could have used distance here as well, rather than the same. So there's not the same different options. There's the same options, but anyway, I'm going to use distance. We want the distance between these 2 points. And we need 4 floats. So we're going to have float, and this is the near offset float, size, scale, length. Probably be consistent with my name, shouldn't I? Fade, length, fade, offset. Let's call them that, make it clear. So this is fade, offset. It's not really fading, but it's fine. Fade length. Obviously the same calculation could be used for opacity or scaling or anything like that. It's just giving us a sort of a value. Near scale, far scale, far scale. Okay, so we got our distance between the two. We subtract our offset. We divide by our length. So we're changing the sort of where the 0 point is by subtracting, and then we're changing where the gradient is by dividing. We can then saturate that to clamp it between 0 and 1, and then we'll just do a lerp based on that value for near scale and far scale. So as I said, exactly the same logic. We're just going to save that out as, oops, make this into a float. This is a very common Niagara thing. This is in what's called a Niagara numeric type. So effectively we're leaving Niagara to do automatically work out what type of value it is. Is it a float? Is it a vector? Is it whatever? Quite useful to work with, but then when you come to the output, it won't let you just plug it in as an output, and you get this thing here, types not compatible. Two options: we can manually create our output. So we're going to create a float output, call size by distance scale, and I'm going to make this a particle parameter, and now that should connect up nicely. Alternatively, we could have made this output into a float, and then that would also just connect, and that will create a new float output for us. So if you do get that error, that's why the Niagara numeric kind of wildcard can't work out what the output should be. The output needs to be explicit. So there we are. There it is. There's our calculation. We'll just apply it. So taking the camera position, taking the particle position, taking away the offset, dividing by the length, and using that to lerp between the near and far scale. I'm going to move this up to above the sprite size module. And there's one option we can do here, or one sort of further optimization. If I turn off current frame data, it's going to use the previous frame's data, so we're going to be a lag by one frame, but for something like this that's fine, doesn't matter. And so let's do this then. So near scale 1, far scale 10, fade offset, let's do, I don't know, 5000, fade length 1000, and this is creating a parameter down here, size by distance scale. And all we're going to do is in our sprite size scale module, plug that in here into the scale curve, size by distance scale. What that should do now is I move my camera away, at some point 5000 units away, they're going to scale up. Let's adjust that to make it a bit clearer. So at 2000 units away, they're going to start fading up or scaling up, and as you get further and further away, 1000 units, keep resetting, they scale up, and you can see that happening there. Pretty cool. If we wanted to do both the scaling up and the scaling down, I could create another one of these modules, SPD001, and in this case I'm going to do a fade length of, let's say, 500, fade offset of 50, far scale of 1, and a near scale of 0. And if I scale in, you'll see that they're scaling down. But we have got a problem here. Now, let me just make sure that is working. Make them a bit bigger to start with. And then as you get towards them, you can definitely see they're scaling down. That's working, but if I move the camera out, they're not getting bigger anymore. What's happening? Well, the sprite size scale here is still reading the size by distance scale, but both of our modules, this one and this one, are outputting to the same value. So what's happening is this module is writing a value, and then the next one's just completely overwriting it. And so we need to make a little change here. Rather than being our type here in our namespace, we want to use the output namespace. What that will do will allow us to have this module namespace modifier. I guess we could maybe have just left it at particles and added the namespace modifier module. That also works. But what we need now is basically it's going to add the module name as part of that namespace, and so we're going to get a and we can see it in here in parameters, particle attributes. What did I call it? SSBD. Size by distance scale. Size by distance scale. Oh. Whenever you're working, always remember to compile and apply your Scratch modules, otherwise it won't work. And just get rid of that size by distance scale because that doesn't exist anymore. So what's happening? So size by distance scale SPD, particles SPD, size by distance scale, particles SPD01. size by distance scale. So we now have two different modules, or two different parameters with the same name but a different namespace. And so because their namespace is unique, we have two sets of values. So if I go into my scale curve now, if I multiply two floats together, and I can do size by distance scale and size by distance scale 1. Okay. Scaling down as we get close to them, scaling up as we get further away. All very nice. Cool. Couple final things. This is now more optimal than doing it in the vertex shader, because it's doing that calculation once, just on sort of per particle, rather than doing it if we were using quads here, which we are. These are just particle two triangles. That would be doing the calculation 4 times, once per vertex, so it should be cheaper. So what else can we do with this? Well, we can make it cheaper still. If we're playing a game, or let's do it in, sorry, let's minimize the, I just realized that the one in the world here is not the one we've been working on, so I'm just going to swap out the template for the class one. There we go. So if we're dealing with a very fast moving player, fast moving character, we probably want this to be reactive and be dynamic. If we're dealing with something slow moving or something further in the distance, we maybe don't need to do this calculation every frame. So what's happening here is this is in particle update. Every frame is checking per particle. It's all on the GPU, it's all pretty cheap. Not something we kind of really need to worry about, but there are ways to make it cheaper still. We can do it once per particle in update, sorry, in spawn, rather than in update. And so if I remove this here, take these values, or these modules, drag them up to particle spawn, and then we're going to do a set new or existing parameter directly, and it's the sprite scale, sprite size. I'm just going to multiply a vector 2D by a float, and so we're going to take the sprite size. So effectively we're taking the value and then multiplying it by something, and so we're kind of resetting it to itself. If I make this 2, they're going to be twice the size. If I make them 0, it's now disappeared entirely. Whoop, way too big. And this now we can just do our SPD values multiplied together. Whoop, SPD, size by distance, yeah. If I move the camera away, you can see the original size is kept, but the new particles are spawning in at a larger scale. And then if we get closer down to it again, now the particles that are spawning close to the camera spawning small, and then as you move through them they're not updating. So for big particles in the distance you want to scale, you probably get away with doing it on spawn. For little particles that you're moving through, you might want to do that on update, just because the camera is going to be a bit more dynamic and a bit more sort of closer and interacting with them. But obviously it depends entirely on your use case and performance and everything that you're dealing with. Okay, one more little thing, just because we're talking about it and talking about performance and optimization and everything here. If I just go back to doing this on update, I'm just going to copy and paste that multiply into here. Now we get this working on a every frame. I'm going to add another option, and let's do it as a kill module, kill particles. Basically I'm going to check the scale of our particles, and if the particle scale is 0, then we're just going to kill the particle. Obviously once it hits 0 size we don't necessarily need it anymore, and so if I did this as a spool by float comparison, the comparison I want to make, this is the near one, so near scale 0, so I'm going to do SPD 001, SPD 001, size by distance scale. If it is greater than 0, I want it to be, is that right? I want the opposite of this, so I'm going to do a just cut on that and only do a knot. And there we are. Is that right? Yes, I think so. So if the size is greater than 0, we're going to get a value of true, and then we're going to do a knot. So we're not going to kill our particles, and that knot just inverts the Boolean. And then we could probably have done it by doing our comparison and things differently in here, but this works too. And so if the size is 0, 0 isn't greater than 0, so this would be false, this will become true, and our particles will get killed. And so what happens is, if I move through this and then move back out again, you can see I've kind of left a little hole. And if I adjust my fade offset value, and make it fade out very quick, you can see I'm effectively just killing my particles by moving through them. Now if your camera can move back and forwards, obviously you don't necessarily want to do that, but there is definitely a use case for this depending on what you're doing. So cool. Okay, quick recap. So we started out looking at materials. Whole thing we're doing is scaling by distance, taking the camera information, taking information about the object, whether that's the object position or the per vertex position. We can do a quick calculation, subtract one from the other, compare it to some values inputs that we do. In this case, a offset value from where we want to start scaling, and then a length value, oops, that's the way around, and then a length value for how long we're going to scale over, and then our scale values, well, we're just blending between two values. So this is giving us a 0 to 1 output. Use that in the alpha of a lerp, we blend between these two values. So 1 to 5, that's going to get bigger, 0 to 1, that's going to scale out. Then we did the same thing in Niagara as a module, just here in a Scratch module. Camera query to get the camera position, particle position, that's already there, we can just do a distance between them. Our 4 input values, fade offset, fade length, near scale and far scale, and then we're just making sure that we're outputting to a module parameter so that we can have multiple of these, and we're just scaling by that value, by creating that scale value. And the last thing we said, well, if we do want to scale these things, if we scale them to nothing, why don't we kill them? Well, we can, no problem, but if we do kill them, they won't come back as we kind of move the camera back through them, so that's potentially kind of a bit more of a visual impact, but obviously it is optimizing them because they're now no longer calculating. And then the last thing, or the other thing we looked at, was whether we want to do this calculation on spawn or update. If we do it on spawn, it'll only happen once, nice and cheap. If we do it on update, it's happening every frame, bit more expensive, but even so, we're all talking about pretty small costs on the GPU here, so not an expensive thing to deal with. Cool. Hopefully that is informative and helpful. Near fading, use all the time. Far fading or far scaling, haven't really used that, but I can definitely think of use cases where I might. And so that was the question I received on the YouTube comment of how do we make things bigger in the distance. Well, I've never done it, but I can make things smaller close up. So it's the same logic, just in reverse. So thanks for the question. If you do have questions, please do drop them in the comments. I'm always looking for ideas for videos, so I'll probably try and help and answer that if I can. As always, if you want to learn more about game art, VFX, tech, materials, all of it, I've got some courses available on Gumroad and Udemy. Currently working through the Advanced Niagara at the moment, so that will be coming soon, to look out for that. Big thanks to all the Patreon supporters. If you want to become a Patreon supporter, the link is below. And yeah, good luck with that, implementing size scaling in all of your particle systems, and I will see you all next time.